Okay, so the first part of question 1 says that an object moves in a straight line at a constant speed from the point 22 minus 3 when t is equal to 3 to the point 12, 17, 20 seconds later. So we've been given 2 points, and we've also been told that it's a straight line. So we've written down our 2 points, and we've written down the equation of a line. So we know we need to find out what m is, or the slope is, and we also need to find out what c is. So we've been given 2 points, so we know that we can find out what m is by using the formula y2 minus y1 divided by x2 minus x1. So after working that out, we're given the slope, which is minus 2. And then to remind us where we are, we're going to write down the equation of a line again, but having filled out what the slope is, in this case minus 2. Now we need to find out what c is. So what we can do is we can sub in one of the points that we know is on the line to fill out the x and y values, and we already know what the slope is, which means that we can actually leave it so c is the only unknown. So in this case, we're going to use the first point that we're given, 22 minus 3, so the y becomes minus 3, and the x becomes 22, and the slope is minus 2 because that's what we worked the slope out to be. So after this, c becomes the only unknown, and we find out that c is equal to 41. And now we can write out the equation of the line, which is y is equal to minus 2x plus 41. The next thing we want to do is figure out the speed of the object. So we're told that it starts at 22 on the x-axis, and in 20 seconds it makes it to 12 on the x-axis. So we can work out that it moves 10 units in 20 seconds, which means that it's moving 0.5 units a second. Now, we need to figure out what xt and yt are. So xt is equal to the starting position and then the speed. So it starts off at 22, and then minus half t, because it's moving half a unit a second. Yt now is figured out a little differently in the sense that it's like the equation of a line, but instead of using say 22 for the x value, we use xt for the x value. So yt is equal to minus 2, so there's the slope, and there's where the x would be. We have 22 minus half t plus 41. Then after we work that out, we are given these two. We are given xt and yt, and we place them like points. So that's 22 minus half t, and then 1t minus 3. After that, we have been told that this happens when t is equal to 3, so it's like there's a delay. So to apply the delay, we just need to sub in t minus 3 to wherever there is t. So in this case, we sub it in where it's minus half t, and we sub it in where it's 1t. After that, we're given the final answer, which is 23.5 minus 1 half t, and then 1t minus 6. The next question says an object is initially at 3, 3 and takes 180 seconds to complete a circular motion of radius 4. But at a center point of minus 1, 3, its movement is anti-clockwise. So we're given the radius, so we write that down, and we want to figure out what the speed is. So it says that it takes 180 seconds to complete a full circular motion, so it takes 180 seconds to do the full 360 degrees, so we can work that it has a speed of 2. Now, the formula that we need is equal to a sine bt plus d plus x, and then we comma, so it's like above here where we have them as 2 points, and then a cos bt plus d plus y. Now in this case, a stands for the radius and b stands for the speed. And we are actually told here that we're told here that it's anti-clockwise. So we know that actually the cos is for x and the sine is for y in this case. So we flip that around. And now we fill out what's remaining. So in this case, the 4 causes because the radius is radius 4. The 2t is because that's the speed, because of the 360 and 180. It's minus 1 because we're told that it's going around the center of minus 1, 3, so minus 1 for x. And then we have the 4 again for radius, the sine because of the y value. It's 2t here because of the speed, and the plus 3 comes from the center point that it's rotating around.